first of all, here's a question that we did the other day. With Gaussian-Jordan elimination, the goal is to get in your augmented matrix, here in the green box, your identity matrix. And if you have that, well, it's very obvious that x is 12 and y is 1. But in order to do that, we do row operations where we first got a 0 here. Then we could divide to get a 1 there, and that automatically solved for the y coordinate. Now, in Gaussian elimination, you would have been done as soon as you got the 0 here, and then you would just go back to sort of like a substitution and regular math method saying, oh, 6y's is equal to 6. Pretty easy to see that y is equal to 1. And then I could go back to my original equation, plug things in, and solve for x. Now, in Gaussian-Jordan, we want to go further and get it right down to 1, 0, 12, 0, 1, 1. And the next thing you would do is, in this green dotted area, make that a 0, still using your row operations. Now, if we get to a 3 by 3, and we did 3 by 3s with Gaussian elimination as well. Did I put one? Yeah, here's the 3 by 3 that we did with Gaussian elimination, right? We got these to be zeros first. And you could do 2 row operations at once to do that. And then we got this to be a 0 next. And from there, we could say, I know that negative 10z is 10, so I could find z. And then I could work backwards all the way and find y and then x. Now, in reduced row echelon form with just Gaussian-Jordan, you want to get the identity matrix. So there's more row operations that you have to do. The idea being it's basically the same thing as you're substituting back in, but you're just doing all the math, so in the end, you have your solution right in front of you. And so that's our plan of what we're going to be doing next. I know we had left a bunch of these 2 by 2 ones for you to solve. But we're going to look at some of the strategies, and maybe I will take, yeah, I'm going to do that. I'm going to just go back to this picture right here. And I'm going to take there we go, nice and big. Just keep that off to the side as a remembrance of what are our steps. And I think it's going to, like, if you think about it, and I'll tell you what to think about, then the steps will make sense as why. If you try to, like, oh, I'm going to color code this in my head and remember this and memorize it, then I'm going to tell you that that's going to be harder to do. But it will make sense why we do the order that we do. Okay? First of all, what I'm going to do with this matrix, well, first of all, I'm going to write out the matrix. So we have 5, 10, and 2. We have 4, 1, 1, 2, negative 1, 2, 1, negative 2, negative 1. And I'm going to tell you to be, and this is going to be even hard for me at times, be focused in the moment. Like, while you're writing down the coefficients, that's a really easy thing to do, right? It's pretty easy to see a 4 and write a 4, right? Like, you don't need very high level of schooling to do that. And because you don't need a very high level of schooling to do that, I'm going to tell you that your mind will be like, I can think about the next thing. And one of the main mistakes is just copying a question down low. because it's so easy. It's easy to copy it down, so it's easy to make that mistake. So we need to have, in this unit, like, someone is like, oh, can I talk to you? No, I'm doing something really, really easy right now, and I can't be bothered, is sort of what is needed in these questions. Okay. So, process. We want to get the identity matrix in the end. There's some different things that, style things that we can go through in this, but we want to get zeros in this bottom corner first, right? Step one. So we put our arrow, and we can do this directly. Yeah. Sometimes a style thing. Sometimes people like to rearrange the rows. They're like, I like to write this one with the 1 at the top. It really doesn't matter, but you can switch rows around if you like. We'll do this one as if you just wrote it down, because it's most typical of students, just to write it down, and then to work with the rows that we have. Okay? So, we need to change row 2 and row 3 to make these zeros. And you can do any operations that you like to do that. So for example, could you see that if you took row 2 and minus 2 row 3s, that would make that a 0. And for row 3, I could take row 1 and minus 4 row 3s, and that would make this a 0 here. So you're allowed to do any multiplication, adding and subtracting of any rows. Our first goal is to get these as zeros. So when we look at, let's just review row 2 here. If I took row 2 and I subtracted 2 row 3s, can you see that row 2 minus 2 row 3s, that'll make a 0. And that's our goal for that one. Row 3, I could take row 1 and minus 4 row 3s, that will make that a 0. Something that we can do, right? We can also type this matrix into our calculator. Okay, this is a good strategy when you're first doing these. You can type it into your calculator and use your calculator to get the answer really quickly. So if any time you think things are going wrong, you can use the answers to check if you're doing things right. Okay. I'll show you what that looks like as well. Okay, so first of all, we're not changing row 1, so I'm going to rewrite row 1, 4, 1, 1, 5. Row 2 is row 2 minus 2 row 3s, and row 3 is row 1 minus 4 row 3s. I'll let you do the math first on your own, and then I'll do it. This is a good way for you to check if I make mistakes, and for me to check if you make mistakes. Okay. The numbers match. Any one of mine that you'd like me to check over? Because everybody was getting something different. as far as remembering the steps, what we are doing here is the same as what we would do if you were solving this 3 by 3 with normal substitution and elimination. If you were solving this with normal substitution and elimination, you would choose one of the variables to get rid of first. What we are doing in Gaussian-Jordan elimination is we're choosing to get rid of the x first. So that's what these two zeros end up representing. We have gotten rid of x in two equations. And what it does is in the bottom corner here, we've created a 2 by 2 systems of equations with just y and z. That makes sense. Now we need to, with just the y's and the z's, we need to eliminate one of the variables. In elimination, you could choose which one. In Gaussian-Jordan, we always choose to eliminate the y and make a 0 here. So it should make sense what the order is that way. And the other thing that should make sense is that when we try to make, right, this one 0 next, you are only allowed to use row 2 and row 3. Because if you use row 1, this other 0 is going to go away. Because there's a 4 in row 1 with the x. If you add it to row 3, you're going to add a 4, and then we're like, oh, we're back to where we started from. So the order should make sense that way. Now we've succeeded in reducing this to a 2 by 2 thing that needs to be solved. We want to get that to be a 0 next. So that's our row 3. What could I do with that? Well, I could take row 3, that 9, and subtract 3 row 2's, because 9 minus 9 would be 0. That seems to be possible there. We're not changing row 1, 4, 1, 1, 5. We're not changing row 2, 0, 3, 4, 6. But row 3 minus 3 row 2's does be 0. Again, I'll give you a little bit of time to do the mental math on your own. How did you do? Yeah.
When you're getting the minus 21, are you multiplying the 6 by 3 and then subtracting by 18?
So what I'll do here is right under this, I'm taking row 3, and row 3 in this column is a minus 3, right? And then I'm subtracting 3 times row 2, and row 2's position there is a 6. So I'm just plugging in those numbers in for, like, row 3 was a minus 3, subtract 3 times whatever the row 2 thing was, which is 6. Negative 3 minus 18 gives me the negative 21. Now, in Gaussian elimination, you would be done, and you would just start writing the equations. You would write negative 7z equals negative 21, solve. Then you would write 3y plus 4z equals 6, and you could plug in the z and solve for y. And then you would take the y and the z and you'd plug it into the 4x plus 1y plus 1z equals 5, and you would be done, okay? Now, that's still some work to do. It seems logically like that should be the easiest thing to do next, but you're going to find that continuing here is the same thing, but just not having to write the variables, right? If you did Gaussian elimination, you would have negative 7z equals negative 21, and you divide both sides by negative 7. We're going to do that the same thing here, but we're going to say I'm going to take row 3, and I'm going to just divide it by negative 7, because that would tell me what z is. 4, 1, 1, 5. we have 0, 0, 1. And, woo, see, think ahead. 3. I think part of the problem is my shadow plays tricks on me. Every time I walk in front of it, I can't see the numbers anymore. So we've succeeded in getting the zeros, and we've also succeeded in getting the 1. Next, we do this same thing that we did to get the zeros in the bottom left-hand corner. We flip it and do the same things to get the zeros in the top right-hand corner. Okay? So you can actually get both row 1 and row 2 next. And you're going to find that in getting these zeros, and this should make sense to you, that you have to use row 3. Because if you get a 0 in another way, without using row, well, first of all, row 3 will make it the easiest to make the zeros. But if you use other rows and don't use row 3, you have the possibility of adding numbers back into those zeros that you don't want. So, first of all, using row 3 will make life the easiest. Well, we can, row 1, I can just take row 1 and minus row 3. Because that would make 1 minus 1, 0. And I can take row 2 and minus 4 row 3s. So row 3 isn't changing. Row 1, you're taking row 1, and the nice thing with all those zeros is this will still be 4, this will still be 1, this will now be 0, and if I take row 1 minus row 3, this will be 2. Row 2, this will still be 0, this will still be 3, this will be 0, and row 2 minus 4 row 3s will give us negative 6. And at this point, you can get row 2 easily to be a 1. Because we can just take row 2 and divide it by 3. Sometimes I laugh at the reduced row echelon form because, yes, you don't have to write the x, the y, and the z, and it keeps it organized, which saves you some writing. But on the other hand, you're rewriting the same rows over and over and over again, so are you really saving that much space? I'm not sure. Okay. Now we only have one more 0 to get. Do you see right here that the only row that you'll be able to use to get rid of that is row 2? If you use row 3, you'd add something to the 0 that you didn't want, and there's nothing in the row 3 that would help. So if you're thinking about it logically, I feel like each time you do it, the steps of what needs to be eliminated will make sense. Okay, so now I can take, I'm going to change row 1. I'm just going to do row 1 minus row 2. And some of you might ask, well, what if I did row 2 minus row 1 instead? Perfectly fine. It also works. That's the beauty of your operations. Every operation that you do, if you find a way to do that, to make that 0, as long as you're not using a row that adds a number into a 0 you already had, you're going to be fine. And so everybody's solution, this is a marking nightmare actually, everybody's solution could look completely different. And then when it goes wrong, I have to find out where in your solution did you go wrong. And I'll show you how I find that out when we get to the calculator part. So, first of all, we are very close here. Can we see that we're rows 2 and 3 don't change. Of course, I write them and I change them. Okay, again, copying down a row that you have already is one of the easiest things in the world. And if you think ahead to what you're going to do next, you can do exactly what I did. Just like, oh, introduce a phantom negative. That's going to happen. Be careful. Okay? So now, row 1 minus row 2, this will still be a 4. This will be a 0. This will be a 0. And 2 minus a negative 2 will be positive 4. Awesome. See? Solving this as easy as 1, 2, 3. And that is our solution. So our solution, the x is 1, the y is negative 2, the z is 3. You can write it as a coordinate like that. You might also like to write it with the actual values. Okay, now we're going to take out our calculator and we're going to type in this matrix. Three rows, 4 columns. And the original matrix was 4, 1, 1, 5, 2, negative 1. Make sure you use the negative symbol and not the subtract symbol. So the very nice thing about your calculator is we can go to matrix, over to math, and right at the bottom, there's the reduced row echelon form button. Push that on matrix A, and we get the same answer that we have. Okay? So you're doing one for practice, and you're worried about, I think I did something wrong. Sometimes you will get big numbers. Sometimes, like I've seen equations that to get rid of a number, you have to do 13 row 2's minus 17 row 3's. And you're like, I feel like this is not going well for me. But sometimes numbers like that do appear, depending on the order that you did them and depending on how you were solving it. So if you know what the answer is, and you're doing work just practicing, I know that x is 1, y is negative 2, and z is 3. And I feel like 3, 4, 6, really? Something in my, I'm like, I felt like that wasn't right. And I want to check this part right here, 3, 4, 6. Well, I know that y was negative 2, and I know that z was 3. So if I do a little check, what's 3 times negative 2 plus 4 times 3? This is negative 6 plus 12. It's 6. Okay, I know I didn't make a mistake there. Right? So when yours goes wrong, that's what I'm doing. I can plug in the right answers into different parts, and I can check where did things go wrong. Okay? Sometimes what I'll tell you on a test or a quiz is I will tell you the answers are integers,
Hello, good morning. Can I just interrupt your class for a
Absolutely.
minute? Okay, come on.
Okay, so the next one is for you to try. I recall the answers are nice. You can type it into your calculator first to get the answers. So if you think you went wrong on a step, you can check. And then I'll put this screen up just so that, well, you can look at your notes too, but as far as formally how you're showing which rows you're changing, that's important because if something goes wrong, then I can also see what you might have done at that step to make it go wrong. Okay, I will put up my solution here. So if you're, now one of the things I did in my solution, I don't know if it's a personal preference thing, I switched the rows around and put the second one first because I like to have a 1 in the top left-hand corner. I find by putting that 1 in that top left-hand corner, you're more typically going to make sure that you use all 3 rows in that first step. So I did first step, I got my zeros. Ooh, that 16 and that 12 causes people problems, but you just have to deal with 16 and 12. So I did 3 row 2s. Oh, actually, what I did here to make life easier, instead of doing it all in one step to get the 0, which I'd probably do if I was doing my own work, I just took row 2 and made it times by 3, and took row 3 and times it by 4, and I got 2 48s there. And then I could write row 3 minus row 2 as an easier step. Okay? I still means that I left this row with a big number, but I was able to solve for z then to get -3. Here I reduced the 48, 20, 21, and -111 back down to the 16, 7, and -37. Got my other zeros, and from there, it was pretty straightforward. So when you get the bigger numbers, like I did in this situation, if you want to take an extra step, I'll move back up to this extra step, you could. You could have also just done, right? You could have said, I can make row 3, I can take row 3 and times it by 16, and then subtract 12 row 2s. That's perfectly fine as well. If you did that as a step, that would, it's not nice numbers, okay? Right? Taking this extra step and making them both 48s, I guess technically I could have taken 4 row 3s and minus 3 row 2s. That would also get rid of that number. So your steps, what you do is sort of personal preference. Like I did the personal preference of changing to the 1 to the top right-hand corner. Not necessary, but I like having that 1 there. This is the whole solution all at once. You can check different things along the way.